Okay, we have a presentation now. Share my screen and okay, nearly there. Okay, so by the way, I had two folders named project, so hope it wasn't confusing.
Well, one of them, there's nothing in one of those.
Yeah, I know. I was like looking at it. So what happened? Yeah, I was like, I asked my son where, but I was able to click on the documents. So it's very weird. Now, I didn't realize you could do that in uh, in Google Drive. You can have the same name for two separate projects. Okay, go ahead.
Hi, good evening, everyone. My name is Najee, and today I'm going to do a presentation on the major limitations of automated testing. So just a quick agenda. I'll start with introduction to what automated testing is. Then I'll move on to who typically writes these tests. Then I'll compare manual testing versus automated testing. I'll discuss major limitations. I will explore when automated testing should be used, and then I will wrap up with a quick conclusion. So what is automated testing? Automated testing means using code to test code. So instead of humans clicking or typing inputs every time we want to test code, we'll write scripts so that tests the code automatically. These tests run after we add new features, for example, or bugs are fixed. Automated tests can improve speed, consistency, and accuracy, but it's only as good as the scripts that we write. So common examples include unit tests, which will test small parts of code, and UI or integration test, which verifies how different parts of code work together. So in short, automated testing helps developers save time and catch errors, but it still requires a lot of human oversight. So who writes these tests? There's a couple different roles that contribute to automated testing in a software project. Developers write unit tests for their own code. Automation engineers handle UI integration and functional automation. DevOps engineers integrate the test into continuous integration and continuous development processes so that they run with every commit. Quality assurance analysts design detailed test scenarios that developers and automation engineers later implement. Let's just do a quick comparison between manual testing and automated testing. Manual test is when a person runs a program, interacts with it, and verifies results by hand. So, for example, if we was testing a web application or a web page, we'll just click through the web page, and we pretty much get just human feedback. Automated testing replaces these repetitive checks for code. The computer compares what the expected results is with what the actual results is automatically. Automated testing is faster and more consistent. Manual testing still plays a big role in catching issues that scripts can't catch. A lot of these issues include usability problems, just visual problems that most humans will pick up on, or just any type of unexpected behaviors. So the major limitations with automated testing. First of all, it could be very expensive. For example, like a small organization or a small team, it could be very expensive to have the tools, the frameworks, and the skilled engineers that's able to do these automated testing. Second, tests need to be constantly updated. So even with a small app, Small changes to the app or small updated features can break the test entirely. Third, automated testing lacks human judgment. I believe this is probably the biggest limitation with automated testing is that even with the best and the most well-written script, we still wouldn't get that human feedback that a human would pick up on. Just when you scrolling, you want things to be smooth, you want a good user interface. So even a well-written test or well-written script wouldn't pick up on things like this and wouldn't get feedback on things like this. And also, it's not good for exploratory testing. So exploratory testing would be just if we have a web application or we have a web page and you tell someone just play around on the web page and let me know how you like it. So even we write a well-written test, humans will just click on things, scroll up and down, just make sure things are smooth. Most automated testing won't give that type of feedback. And lastly, the different type of environments. A lot of times with different browsers, different devices, different OSs, automated tests could result back in inconsistent behaviors. So while automated testing is fast and reliable, it still needs a lot of human oversight to stay effective. So when should we use automated testing? Automated testing works best when we have repetitive or predictable tests like regression testing, unit testing, and load or performance testing. But exploratory testing or user experience testing requires a lot of manual input. The best approach is to use a hybrid approach, which is using automated testing for consistency and manual testing for creativity, human intuition, and just the human feel and the human experience. So in conclusion, automated testing significantly improves speed, accuracy, and coverage, but it doesn't replace human insight. The most successful teams combine both approaches, using automated testing for reliability and manual testing for adaptability and judgment. That's the end of my presentation. Thank you, everybody.
Very good. I'd just like to mention that where I work, there's also another problem is that if you're dealing with if you're dealing like with something that uses a database, so or writes or reads from the database, and so let's say, for example, you're testing creating a person, but once a person's there, you can't add them again. So you have to like roll back the database. It gets very complicated. Every time you wanna do something, you have to every time like there's a database change or something, you have to like create an initial the initial database that you're testing with. You have to redo it, save it, and then run, right? So it gets very a lot of time spent on this. Yeah, you're right. You're 100% correct that it is very time consuming automated testing. Yeah, to always get, and also I've seen also is there's a big issue like with delays. So let's say there's like a 5-second delay sometimes. So then it may or may like you were saying, it's not as good as a real person because you can't tell like why it has that delay, right? Is it whose fault is it? Right. So um okay, so just a reminder, so we having presentations the project presentations are going to be um, where it's going to be. By the way, if I don't give you a grade for a presentation, just remind me uh, to enter it. Um, Upload, where is it? So projects are here. So, sorry, schedule. So, um, right, so it should be this coming Tuesday, right? So do not come in, sign up for your slot, right? So, where is it? Here. So it's going to be this coming a week from today, right? And so don't come in, sign up for the slot, right? Actually, I was going to do that next. Just go through quickly what's entailed for the project. So, okay, so as you could see, I'm hoping that you'll take about 5 minutes to present it. And then you're going to create that Replit link. That's where we have some people signed up their slots. And there's one person, I forgot who, I changed their, I think it's Fedi. I think I changed your pattern because we're not doing the command pattern. We're just doing 9 patterns. So we skipped that. Um, and then, so basically, the idea is that you're going to present it just the 5 minutes, just to quickly show me that you don't have to run. Your code doesn't actually have to compile. I'm not going to test it for them. I actually just want to see your code and you understand what it does. And so okay, so let's quickly go to that. And then I'm going to look at it afterwards when I finally grade you. So, um, so I show over here, um, how I'm going to grade you is I'm going to there's a UML diagram, which is really simple. All you got to do for the UML diagram is, let's say you're doing observer pattern, right? So you just go to Google or maybe even ChatGPT. Nah, do it on Google. Uh, do a little work. Uh, so you go to Google and you look for, let's say, observer pattern UML, and you just find the UML, and then like over here, and then you would where it has the objects, you would just put your own classes there, right? So instead of whatever subject could be something other that's being watched, right? So in our case, it was a stock market. The observer was a web browser or whatever, right? So that's all you have to do for that. So not a big deal. You just have to, copy it and put in the actual classes that you're doing. Okay. And then the second part, that's 10% of the grade. Then unit tests, which I'll show you. Like unit tests, let's say we have I'll just show you quickly how to do it. We've done it before, but unit test is basically, actually, it's an automated test, right? Just like you said. How do you pronounce your first name?
G.
Najee. Yeah, just like Najee said, that so let's say we have a math class and let's do something real simple, int add, and uh, by the way, again, you don't have to actually have this code run it. You just have to have it written, okay? Because a lot of times on Replit, it's hard, especially unit tests. People complain that it's difficult to set up. So you don't have to just write it on your machine and just upload it to Replit. That's all. So that way, all the code's in one place. It's available to me, and it's just shared with me and you, so you don't have to worry about someone else. So for example, so let's say we return I1 plus I2. Did I do that right? That should be an I. Okay, and then, so if I want to create, let's say, a unit test, let's make this public. So to make a unit test in IntelliJ, which that's the only one I've ever used. I don't know why people use other ones. So we do generate test, and we want to, and then I say I want to test this thing. It's not really a big deal. Oh, good. So is this a problem? Oh, yeah, I got to do that. I don't know why I keep having to do that. Uh, okay, so this is my test. So I have to write 2 unit tests. So I would do add. Uh, I would do. Let me just call it test. Add 1, and then I would just copy this, and let's say call this. You need the first part here, this org something, whatever. And this will be, let's say, test 2. Okay, so let's say I'm testing the math class. So I would do new I would do, let's say, math, dot M, oh, let's do normal, equals to new math. And then I would test, let's say I want to make sure that 1 plus 2 equals 3. So I would do add 1 and 2, and I'm sorry, I would do math.add. And then the way I would test it would be, there's, see, with this, in other words, the question is, what does this J unit do? So what it does is it actually does a bunch of things, but one of the things it does is it gives you access to a bunch of methods that come for testing. They're made just for unit testing. In other words, all they do is make sure that the value is true or false. In this case, we're going to do assert true, meaning that's going to make sure that this returns true. In other words, if this class is not broken, this should be equal to 3, right? Did I get that right? So that's one test, for example. Now you should try to look something like that would maybe fail. So maybe a second, no, try to write a real test. So don't just do like 1 plus 2 equals 3 or 3 plus 2 is equal to 5, right? You could do that. Well, let's just do that for a second. So then let's say you do that and then you run the test. So the way you do that is usually you just do, oh, you can't run all of them? Maybe I could do this. Oh yeah, maybe here. So let me run all of them. So it's gonna automatically run it. And hello. Okay, here's it going. And look, so on the left, I don't know if you could see it, on the left, let me just turn for like a second. You can see that these are green, so that means that they worked, right? It passed. But let's say, for example, I would have done 6. By the way, there's like many of the, so let's say I would have run this one again. You'll see that it's going to give me, it's going to blow up. See, it failed because it expected this to be true, but it's not true, right? It's not equal to 6. So I could do something called assert false, which will return true, right? Because it is false. So then if I run this again, it would actually work, right? Because it is false. But try to be creative. Like try to think of something maybe, uh, that something like a boundary condition. So for example, try adding a -1 and a +1 and something like that, or -1, 1, 1, 1, and I don't know, something like that, or just, or try to do the overflow, like try to use like a really big number, something like that. I don't know, just try to be a little creative, so it's not like a stupid test. Actually, let's see this. So this one probably will work. Yeah, the 0. Yay. Okay. I think what I would do over here is maybe I forgot what it's called. It's called integer. I think it's max value. That was what it is. No, max value. Uh, let's try this. What happens if you had max and min? I don't even know what this would do. So the min value here is going to be whatever, and this is going to be 2147, 8. So it should not be, it should be, and this was negative 1 more, right, than the max. So it should be equal to -1, right? Let's see if that works. It's more fun, right? So let's try that. So this should be equal to -1. Um, Hey, it worked. Okay, so that would be more interesting. So we passed in a min and a max, and they were off by 1, which is what we thought it should be. Okay, so that's like so that's how you do a unit test. Okay, so 2 unit tests, but again, try to do like maybe one that's basic and one that's like testing the boundaries, the boundary condition. Yeah, not just the same thing twice. Um, Then, okay, so far so good. So we went through the UML diagram, and I have all this in the document. And then there's a code, which I said is good, should be 3 classes, right? And then at least 3, but that's it. You don't have to write a game. A lot of people think, okay, it's time to write a game. Nope, do that for another class. I don't, I only need 3 classes. I got enough people to grade, and yeah, so I'm just gonna look at 3 classes so that I show that you know how to use the design pattern. Here are the steps over here. You create your own replit. So and just send me a link. I could look at your code afterwards. Um, Make sure you use the Java coding convention for your code, which means, like you've noticed, that we always use lowercase, camel case, right? We always start with lower case, except for when we're doing a type, right? When we're doing a type, like a class name, that's the only time we start with a capital, right? Um, by the way, in case you're interested, and when you're doing um, constants, right, you notice how it's always up there. The whole thing is uppercase, and it's the words are joined together with an underscore. Okay, but nearly 90 most of the time it's going to start with a lowercase letter, right? So that's how Java does it. Um, C sharp does it a little bit different. They start up, everything is uppercase in C sharp, whatever. But this is a Java coding convention. Uh, only the types begin with uppercase letter, and types start with lowercase. Huh? Types begin and types start. Oh, I'm sorry, I should write methods. Start with lower methods and variables. Okay. Um, Only this is also standard Java, so you only have 1 class per file, so you should have at least 3 files. So at least 3 classes, 2 unit tests. Um, so for example, um, like this would be an example, you would have 3 3 objects, I guess. You would have the observer interface this is for the observer pattern, right? So you would have like this is an example, right? So I should write example. All right, so for example, if you were doing this, you could have one class would be the interface, one would be a web page, which is observer, and then you have stock market, which would have these methods, um, add observer, remove observer, notify observers, right? So, and that's all you have to do. So you don't have to, um, and then, for example, for a unit test, you would have a quote add observer, and then you would somehow test to notify that the observer got notified. Now, this is a little bit difficult because if you just print something to screen, oh yeah, that's very important. When we're discussing unit tests, notice how we're always testing return a value, right? So what you should probably do is you should, so for example, you should have a way of, um, in other words, since these tests are run by themselves, so if you can't really test if something was written to the screen. So for example, let's say I have, um, I'm just making this up. Let's say I have I'll do it real quick. Let's say we have um, observer. Right, so, and then I have, within the observer, I have a notify method, right? So over here, the notify is, um, is void. So, well, there's not, okay, you know what, let me find out the actual, if I have it, do I have observer? Here we are. So if I go here, let me just see if I can here. So for example, over here, we have the stock market and it's being observed by let's say the New York Times and the Post, right? Um, and the government, okay, so, and they want to be notified. So in this example over here, let's say, so one test could be, let's think for a second. So one test would be that if I add observer, I want to make sure that that observer got notified. So over here, for example, the New York Times um, has a notify method, but the problem is that it's printing. So how do I know that it actually got notified, right? So the way you would do that would be, let me just see for a second. It's a good question. How would I do that? So when um, I would have to, it'd be very difficult to do that. When I would say, it would have to, uh, um, yeah, it wouldn't be that easy to actually test that part because how would you test it? Because it would write to the screen. The only thing I could think of is if when you buy a stock, it would what it would do is let's say you would return a string over here, and then um, uh, and then over here when you notify over here, it will also return a string. So and then where are we up to again? Um, and then we do have to change the government to be string. And this, instead of printing it, it's going to return it. Okay. This would just return that. And then, or it would do both. Okay. Or maybe um, okay. I don't want to undo everything, but it, it would print it, but it would also, um, just return notified or something. Just to see that it was notified. Okay. Government. This is a hard one most of them are much easier. Okay. So this is a hard thing to do. So so this would return an observer notified, and then you would have the, over here, the same thing, string. and you would have return. This is a government, a newspaper. And then it was called from the stock market. So the stock market is going to, when you buy something, it's going to, um, let's say, um, you do like, and then you would do messages, and then you would just do messages plus equals to, okay, so every time it's no notified that it's going to, what? What did it like? Each observer and observer didn't like. Oh, I did something wrong. I shouldn't do my stocks. I should do, oh, here. Okay. So then, and then I return messages. So this is the way I could test to buy to see if it gets notified. Phew, that was a hard way. That was a lot of work. Um, but at least I have a way of testing now. Okay, so for example, if I write a unit test over here of buying, I could, let's say over here, um, uh, I'm just lazy right now, so I'm just going to copy all this, and then I'm going to create a unit test over here, and um, oh, wants me to do all that again. Okay, so like over here, oh, what happened? It didn't. Oh, I forgot to go back here. And I forgot to do, forgot to click that. Okay, so I just needed to put in that testing there. Okay, so let's say over here I do this, so I could assert that um, that when I buy from Microsoft, I could assert true that that this is going to return a string which is going to contain or contains this string, which is who is notified the newspaper, right? Newspaper, right? So something like that, okay? So this is an example of how you would have to do it. Most of the times it's much easier, okay? Like math was much easier to do it. Over here was if you want to check to see if the buy, when you bought a stock, that the newspaper was notified, you would actually have to, um, you would have to do all that work. Okay, so it gets a little more complicated for that. Okay, but it's better than running to the screen because let's say you want your unit test to run anywhere in any environment, like let's say there is no screen, there's no video card or whatever, right? So or, there are ways to test the output of the screen, but I don't know, it doesn't always work. So it's always better just to have it return the string and compare the return value, okay? So that's what I would test. Um, Something like this. So actually, let's just see what it,
So you can have your, for the project, you can have the unit test just like in the main, and like the driver. You don't have to like make a new class for it.
no, you should do it like this. No, it should be like this. It should be unit test.
Yeah.
I just copied the code from the main. Um, okay, yeah. Okay, yeah, over here, I just want to print it maybe. Okay, whatever. This is an example. So this should print something out when it gets notified, okay? I'm not sure exactly what, I didn't test it yet, but it should say newspaper. Like if we ran it, I could run it now. Let's just see if it does that. It might fail or might not, I don't know. I didn't test it yet, but that's how I would do it. That's the general idea. Uh, oh, so it passed it. I don't know exactly. Yeah, so it did contain it. Let's see, me just tested it real quick. Let me make this newspaper one. And again, you're not going to have to run this for me. You just have to write the test, okay? Show me how it works. That should fail. Yeah, it failed. Okay, so that really is working. Okay, so actually it is working. Um, okay, uh, get rid of the one, and that will work. Okay, so yeah, why is it underlined? I don't know. Okay, I don't know why it's give me that. Okay, so that's the idea. What else is there? And then there's the UML diagram, which I told you, you just, you know, just change an image, in Paint or something, right? No big deal. If you want to, you could go into, do one from scratch, but you don't have to, right? There's no, requirement for that, okay? So, and that's it. So it shouldn't take you more than an hour maybe to do it. So, okay, so let's do one more design pattern, the state pattern, and then we should be done with all design patterns, and then I'll have a little summary. So, okay, so, so let me go back. So let's do I'm sorry, which one, what did I say I was going to do? I'm going to do the state pattern, right? Um, so the state pattern is really cool. Um, should we do, I rewrote it, so I wrote earlier today, so I'll just show you what it looks like. So, um, okay, so the state pattern is, let's say, for example, I'll start like from the beginning. So let's say I have a car, right? And the idea is that if you drive a car, it has a transmission. So basically, you want to be able to knows what happens when um, when I shift up or shift down, right? So then, um, I want to be able, for example, over here, I want to be able to create my car, and then I want to be able to basically car dot uh, drive. Oh, I don't have a drive method. Oops. Let me put that in there. So I need a drive method. I'll show you in a second how it works. Okay. All it's going to do is call Okay. Okay, so what I want to do is, first I want to call drive, and then I want to car dot shift, let's say shift down, then I want to drive, and then I want to, shifting means when you want to change the gear one way or the other. So then I want to shift up, and then I want to drive and see what happens, right? Shift up and up, and then I want to drive again. So we'll see what happens when I shift. Okay, so that's what I want to do. Okay, so I want to make it very simple, and the idea is that instead of like one way to do it, which is the way that a lot of people without objects would do, would be you would have a bunch of if statements. In other words, you'd remember what is my current state, and then say if current state equals to park, then I'm allowed to, when I shift down, I could do this. If I shift up this, and it'll be a whole bunch of if-else statements, right? It get very, very, very complicated code, right? That would be like without this design pattern, right? You would have all the code in one like big, huge logic statement, right? And it would be a big mess, right? I guarantee you. Okay, because every time you added different states, like a car could have I think my car has 8-speed transmission. Some cars have more or less, right? So, and I think that's 8-speed. I'm not sure if it includes reverse. So you have like 8 different possible states, maybe 9, if you have park. So and then each one, you allow different things to happen, right? You allow, the code is going to look really, really complicated. And when you change something, it's easy to break it. Okay. Besides the fact you don't understand how it's working, but it's like, because it's a bunch of if else, if this, then you're allowed to do this. If this, then the acceleration should be limited to this many RPMs, and not acceleration, what's it called? The RPMs, right? The revolution should be limited to, whatever it is, to 5,000 or something. So, or maybe in all and then if it's a neutral, what does it do? So it gets really complicated. But so it's easier if we could look at it as a bunch of different states, right? So the idea is we have a park state, we have so within it's very similar, if you remember, remember we did with the duck, with the strategy pattern? Remember we had that each duck was a combination of different strategies that we passed in. So this is very similar, except that we're putting okay, well, we'll see actually why it's not the strategy pattern, but it's very similar. And the idea is that we're having a bunch of different drives based on what state you're in, right? You might say this, okay, people ask like, this sounds very much like the strategy pattern. Okay, we'll see why it's not. But the idea is, so you have a park, you have uh, which just does park, doesn't do anything. And then you have a drive, which just drives. And then you have the reverse, which just does, oops, reverse. Okay, okay, driving in reverse. Okay, so, and maybe drive should be drive forward. Drive forward. Okay, so these are the 4 different states. And then what we want to do is we want to make it so that it's not complicated, meaning that the main code is going to be very simple. So if we look at our car, you'll see that there isn't too much here. Basically, we have, when we shift up, we see basically we start with a current state, which is park. And then when we shift up, we see if there's something next, right? Then we move our state to the next state, or we say we can't shift up anymore, and we shift down the same thing, but we check if there's a previous, right? This is sort of like a linked list, sort of, right? That we have a pointer to the next possible state, right? So if you look over here, for example, when first I create the states, and then within each state, I have I pass it the previous and the next state. So initially, when the program runs, there's no previous or next for any of them. And then in the constructor, I say the previous to park is you could go in reverse, and the next of park is you could go into drive. And the reverse, if you're in reverse, you can only go into park. And if you're in drive, you can't go forward, you can only go back into park. So this is my shifting logic. Okay, so it's a very simple logic. So I could only go from, I explain how to get from one state to another over here. And then, and then the rest is pretty simple. So all I have to do is check to see if there is somewhere to go. And if there isn't, I go. Otherwise, I just say I can't go anymore. And then the only other code to show you would be this code over here, which is where we pass in the next and the previous. And it looks like I don't really even have to, I should make this public. This is um, a abstract class because it has a little bit code. And I don't think I'm using this, so I'm gonna take this out. So I'm not using it. So I just noticed I'm not using it, so make it even more simple. I'll just, I like putting specifically here. Some people at work don't like when I do this, but I like things being always set to a value, even if it's the default value. So, and then over here, when I created the car, the transmission objects, I could get rid of all these nulls because they're not being used anyhow. And just go over here, make it simpler. Get rid of this. Everything is a lot simpler. And then drive, park, get rid of all this stuff. Yeah, I don't need any of this stuff. Okay. Yeah, I made it too complicated. I overcomplicated it. Okay. So now, okay, let's try it. Okay. And let's see if it works. So you go to main and let's see. So we do like, let's just run this. Okay, so so first we're going to be in park. What? Oh, it doesn't know to run main. Oh, I did the wrong one again. Sorry. Run main, I don't want to, how do I get it to? I don't want to do that. I want to run this one. I do run. No, I don't. Oh, here, main. Here we go. Okay, so first it did park, right? Then we shifted down, it said driving in reverse. And then we did shift up, so now it's in park, right? It's back where we were. And then if we shifted up again and we drove, let's say we do that again, let's try this again, then it will only let us shift a couple times. Cannot shift up anymore and still in drive, right? So so this is so this now how would we write a unit test to check this, right? How would you do that? So, well, so the way we did it was our drive is we made this void. So to write a unit test, we just have to have it pass back a value. Uh, I would just say a string, and we uh, return, oh, I would say um, string, or we just return this. Then we have to change this to return a string. And then I have to change all that. But then I'll be able to test it easily. So over here, I could just pass a string. Um, I would, I mean, in real life, I would do something like, uh, and then I would do print line S, and then I would just do return S. You get the idea. So let me just copy this to another two and try. And then I'll just copy this to the reverse, I think. Uh, oh, it's the park. Oh, I know what just happened. Sorry. So we just do string s equals to park, and then print s, and then return s. And then now we could test over here, right? We'd be able to test return value, like we could do something like this, s out, um, and then this should print out. Um, so then we could write a unit test. So for example, um, here, let me just, like, so for example, let's say we're doing unit test for this, so we could do generate a test for, um, should be car test. I have to pick a method. We'll just call this car test. Where is it? I just, I always forget the thing, so there would be car test. And then I would go back to my main, just copy this. And so my unit test would be something like, let me check this out. Um, it would be like, I would just copy this, and then I would make this an assert, um, true, assert true that car dot drive, um, let's say, I'll just do contains, and, um, it should be park, right? Initially, it starts out in park. So park is going to have the word park in it. So I would do something like that. Okay, so let's just run this unit test over here, see if that works. And so that would be one unit test, right? We, yep, it actually, see, but we were able to write a unit test, even though it prints out the word park, but that's not what we're testing, right? We're testing the return value, right? Because that's easy to write a unit test for, right? As opposed to, um, when he writes to the screen, it's, yeah,
So when you're making a unit test for, let's say, the builder pattern, since the thing the builder pattern really cares about is if the object actually builds or is returned null if the mandatory information isn't given or if the verified isn't passed, would your unit test be on just the object being built or?
yeah, I would test it one way where it's supposed to work and one way where it's supposed to fail. And then I would assert true that it's equal to null when it's supposed to fail, or assert false whenever it's not equal to, yeah. I just make sure. Yeah, that would be one, yeah, that would actually be easier, pretty easy. Like this one, we had to finagle around to return a value. But then you just test whether it actually built it or not. Um, And then where are we up? Oh, yeah. So I just want to do a summary of all the design patterns. I just made a little summary, and then we're done with design patterns for yeah, probably for the rest of the semester. I'm not going to really spend time with it. So just to review, the iterative pattern, it basically it hides how a list is actually stored, right? We use a generic type of way of going through um, um, a list uh, is is stored probably in an object, right? So it hides it, so we don't have to actually know the actual way it's stored, right? A how list, or instead of how list, it should say the implementation hides implementation of I should say collection of how, um, okay, so let's just do a list. Okay, it's stored an object. The state pattern basically does the open close principle. It's very similar to the strategy pattern, right? Because the way it works is we could, in other words, it's really easy for us to go over here and add a new type of transmission, right? All we have to do is add it over here and then plug it in over here and we're good to go. Nothing else has to change, right? So we're adding, right? We're open for, we're closed for modification and we're open for extension, right? We're able to add objects, but we don't have to modify existing, right? So if our car is driving okay, and we want to add a new, a new gear, like neutral, for example, right? We didn't do neutral. Suppose we want to do that, it would be easy. We just have to add it over here, add it over here, and we're good to go, right? So, so it's basically the strategy pattern. The difference between the state pattern and the strategy is that, um, the state pattern, it's usually strategies, for example, is like, like for a duck flying. So usually how a duck is going to fly is going to be the same throughout the whole program. You know, it's strategy is just a way that you stay with that the whole time. It's like one in many different ways, but once you pick the strategy, you stay with it. The state pattern is like a car where it's keep on going back and forth from one state to another. The other difference is that the state pattern is decided by the program, meaning the program decides on the which state you should be in. Now, as you shift, the program automatically tells, well, if we're in this, we're going to go do this. As opposed to the strategy pattern is where the user usually picks a strategy. For example, let's say you're paying by credit card, right? So that type of payment strategy will be passed in. If you pick a cash, there'll be a different payment strategy, right? So based on the user actions, that determines the strategy. But with a state pattern, it's more indirect, right? You just push the accelerator, you don't realize that the car is, keep on changing gears and all that. The observer pattern, we said, does basically the strategy, which is basically it's just like the observer is just um, what? It's like a special case of the strategy pattern, right? So it's like a very well-known way of doing the strategy. So it's basically the same idea. They just add observers without changing the code. Builder pattern controls object creation. Memento, it takes an actual picture of an object and it stores that picture in another object, in memento object, right? Right. So, and then it just keeps track of those. The decorator pattern, what it does is it puts the objects together so that um, calling a method in one object triggers um, triggers the uh, method being called in all objects, right? Connected objects. Okay. A factory pattern has to do with creating an object. I'm sorry, decides which object controls object creation, basically. It tells you which object is going to be created, which object, I should say, right? Because the builder also creates object creation, but it's one single object, right? So the builder controls single object creation. Uh, creation, that's object creation of one object. Well, because some people get confused with that, but the factory controls which object is created. Right, so it's in control of deciding which one's you need. The singleton protects the global, right? So you can't just randomly, it protects global and also, um, yeah. Oh, and the last thing is strategy, which we said is open closed. Okay, so this is a brief summary of all the patterns. After a while, they start looking the same, right? So, because they really are basically have wanted, the idea is to make code simpler and clear. Okay, so you have a good evening. See you on Thursday. Okay, so we're done with design patterns pretty much.